Introducing the future of green energy. Ecological, economical. Introducing Ecoremedy.
Hi, I'm Rich Madeira, Vice President of Engenuity Energy. I'd like to invite you to take a virtual tour of Engenuity Energy's Ecoremedy Development Facility located on the campus of Harrisburg Area Community College. The development facility represents a partnership between higher education and private industry that will better prepare the future workforce entering the green economy while working to advance research in the testing of biomass fuel stocks and system designs. Let's get started on the tour. The Ecoremedy process begins with the delivery of fuel. Here we can see the arrival of a shipment of mushroom compost. The material is delivered via a tractor trailer with a moving floor. This type of trailer is typical of the agricultural industry and is used every day to transport various agricultural products such as mushroom compost and animal manures. Chances are, you drive by these trucks every day, never knowing what's really inside them. The moving floor trailer backs into our specially designed receiving bay, which acts as an airlock in order to control odors associated with the stored materials. To further control odor, we induce a negative pressure environment by drawing air from the receiving bay across the stored material. The material is transported from the receiving bay to the fuel metering bin via an enclosed conveyance system. Here at the Ecoremedy Development Facility, we are using standard agricultural equipment to demonstrate how easily Ecoremedy can be integrated into the existing practices of the agricultural industry. Once inside the metering bin, the introduction of the materials into the gasification system is automated, requiring little interaction or supervision by the operator. Here in the fuel metering bin, we can also see the air duct associated with the air being drawn from the material in the receiving bay. The Ecoremedy process is designed for ease of operation. The system utilizes programmable logic controls and touchscreen interfaces in order to maximize system operations while minimizing the need for operator interaction. From the control panel, the operator can monitor the entire system. The skill set and ability level of an Ecoremedy operator is roughly the same as that of an individual who presently operates or services conventional boiler technology. After leaving the fuel metering bin, the material passes under a guillotine gate. The guillotine gate controls the fuel bed depth, which can range from as little as 4 inches to as high as 22 inches, dependent upon the type of fuel being used. The material is conveyed through the gasifier chamber via advanced conveyor technology and variable speed drives. Together, the fuel bed depth and the speed at which the material passes through the gasifier will ultimately determine the load on the system, as well as determine the amount of energy produced. As the material makes its way past the guillotine gate, it enters the gasifier. The 4 large valves seen here represent Ecoremedy's 4 stages of gasification. The valves control the gasification air fed below the fuel pile. The material is gasified in a substoichiometric environment with an average temperature of about 1100 degrees Fahrenheit. Rather than burn the material, it is slowly heated in this environment and is starved for air so that it does not fully combust. Instead, a thermal conversion takes place where biogases are formed and driven off the material. These gases, known as syngas, are then transferred down the refractory line ductwork into a secondary combustion zone known as an oxidation chamber. In the oxidation chamber, the syngas is met with air supplied by the overfire air valves. These valves are strategically positioned to create a cyclonic action to thoroughly mix the combustion air with the volatile syngas. Once ignited, the resultant fireball can reach temperatures in excess of 2400 degrees Fahrenheit. Ultimately, the achieved temperature is directly affected by the variability of the fuel, as well as its moisture content and BTU value. By looking down the Morrison tube, we can see the ignited syngas as it reaches the combustion zone. As the flame intensifies, it creates a fiery inferno within the boiler, which produces steam. For demonstration purposes, the steam produced at the development facility is vented to atmosphere. Ecoremedy emissions are clean. By definition, Ecoremedy is already carbon neutral, as it focuses on using only naturally existing materials, which are not grown for energy, and, if left in their natural environment, these materials would otherwise decompose, releasing methane gas. Methane gas is a greenhouse gas 20 to 30 times more harmful than CO2. In some cases, materials used by Ecoremedy, such as chicken litter, actually have their own constituents such as urea and high alkali content that work to self-scrub their emissions through chemical reactions that take place during the gasification process. Even when using self-scrubbing materials, Ecoremedy looks to utilize best available control technology for its air emissions. The development facility at HAC is not only home to Ecoremedy, it's also home to advanced pollution controls. Before leaving the Ecoremedy system, flue gases pass through an electrostatic precipitator, or an ESP. The unit at HAC is manufactured by Cambridge Environmental Technologies. This next-generation technology is extremely versatile and is ideally suited for the biomass industry, capturing particles smaller than 0.25 microns. Its abilities exceed today's environmental requirements and are positioned to meet those of the future. When it comes to energy production, Ecoremedy is not only clean, it's reliable and can be depended upon 24 hours a day, 7 days a week. It's also scalable. The technology operating in the development facility is ideally suited to process up to 1,200 pounds of material per hour, producing enough energy to offset fossil fuels which would typically power an industrial-sized boiler. It can be scaled to meet the thermal and electric needs of a commercial office complex, a college campus, or a manufacturing plant. Or it can be scaled large enough to meet the energy needs of over 20,000 homes. Ecoremedy technology not only produces clean, dependable energy, it also captures vital nutrients from the all-natural materials it uses during the gasification process. Ecoremedy has the distinct ability to control the condition of the recovered nutrient as it exits the system. This includes carbon content. Ecoremedy processes the captured nutrients into a form that is ready to be granulized and reintroduced into agriculture as all-natural fertilizer, feed supplement, or biochar. The content of the recovered nutrient captured within the ESP is actually comparable to that of potash, which is vital to farming practices and a limited natural resource. Our tour of the Ecoremedy development facility at HAC has come to an end. I'd like to thank you for joining us today and let you know that if you have additional questions or would like to learn more about how Ecoremedy is making a difference for energy and the environment, please feel free to contact us at www.engenuityenergy.com.